Hey guys, and welcome back to another video on the channel. In today's video we're going to be taking a look at question 3 from the 2023 Specialist External Exam Paper 2. Okay, now you would have noticed with each of the videos I've split all the questions up into their own video. That way if you want to go watch a specific question on the channel you can, rather than sitting through the entire video just waiting for one question or two questions. In saying that though, the full external exam is still up on YouTube. The link is in the description below. If you need a specialist external exam bundle pack, the link is also in the description below, so get your downloads if you need it. If you have any questions at all during this video, leave something in the comments and I'll try my best to answer it. But otherwise, let's get straight into question 3, okay? Now, this is a calculator question as well, okay? Now, given that 2i is the root of z squared minus pz minus q equals 0, where p and q are real numbers, determine the values of p and q. Okay, so if we know a solution is z equals 2i, that's one solution. Complex numbers always come in conjugate pairs. So for example, if z is equal to, let's say, a plus bi, then its conjugate would also be a solution. So a minus bi. And the conjugate is the opposite sign on the imaginary unit. So here, because they said z equals 2i is a root, what that also means is its conjugate is also a root. So z equals negative 2i is also a root, okay? If you want to write them as factors as well. Now, because it is a quadratic expression with a coefficient of 1, this can be written as z something here times by z, oh, if I can write properly, z something here, brackets. So we can write it as a product of two linear factors. Now, we have both the roots. To write things as a factor, you have to get them equal to 0. So you'd have to move this across and this across. So the two factors would be z minus 2i, and the other one would be z plus 2i. Now, because it is a quadratic expression with a coefficient of 1, multiplying these two linear factors will actually give us this expression here. So all we've got to do is just multiply out these linear factors and see what we get. So when you multiply these guys out, you probably don't even need a calculator really for this one here. So you multiply it out like this. So here, that would give you, starting with the first term, z times z, you get z squared. Then you're going to get z times by 2i, so it's positive 2iz. Then you're going to have minus 2i times by z, so it's minus 2iz. And then here you're going to have minus 2i times by positive 2i. So that's going to give you minus 4i squared. We can see these guys are like terms and they're opposites, so they cancel each other out. So all we're left with here is z squared plus 0 minus 4i squared. Now I is the square root of negative 1. Therefore I squared must be negative 1. So here, that minus 4i squared turns into a positive 4. Now let's line this up with what they have up here. Here, z squared matches up perfectly. Now there is no z term. So there is a 0 z term there. So imagine plus 0z. So that is actually going to be the value of your negative p. So negative p is equal to 0, therefore p equals 0. So it can only be between C or D as our answer straight away. These ones are incorrect because they got p as negative 4. Then we just text the next value. So here we can see the term, the positive 4 is equal to your negative q. So here, negative q is equal to positive 4. Therefore, q would be equal to negative 4, dividing both sides by negative 1 to get the q by itself. So the correct answer here is C. P equals 0 and q equals negative 4. Would you need a calculator? Probably not. You could do this all by hand, but a calculator might make it a bit faster as well. Okay? Alright. Now, if you have any questions about this one here, you need to study complex values a bit better. Complex numbers, sorry, not values. If you need a practice external exam, link is in the description below for the specialist external exam bundle pack. If you have any questions about this one here, leave it in the comments. But otherwise, I will see you in the next video.